Hi everyone, how are you? Welcome back to my another video on calculus, and for watching my next videos you can subscribe this YouTube channel. In this video we're gonna solve some calculus problems which are about exponential functions and natural log. So let's start them. The question is, find the derivatives of the given function. The first function is y equals e to the power of 2x, and functions like this one are called exponential functions, and as you know, e is the Euler number. And for finding the derivative of the exponential functions, we should know that the derivative of e to the power of x with respect to x equals e to the power of x, and the derivative of the e to the power of u with respect to x equals the derivative of u with respect to x times e to the power of u. And for this function, u equals 2x and y equals e to the power of u, and the derivative of y equals the derivative of u times e to the power of u. So the derivative of y equals the derivative of u with respect to x equals 2 times e to the power of 2x. The next function is y equals x times e to the power of x squared. And before finding the derivative of this function, we should know that the derivative of u times v with respect to x equals u prime times v plus v primes times u. And for this function, y prime equals the derivative of x, which equals 1 times e to the power of x squared plus the derivative of the e to the power of x squared with respect to x times x. And the derivative of the e to the power of x squared with respect to x equals the derivative of the x squared times e to the power of x squared, and the result is 2x times e to the power of x squared. So y prime equals 1 times e to the power of x squared equals e to the power of x squared plus the derivative of the e to the power of x squared equals 2x times e to the power of x squared times x. And finally, y prime equals e to the power of x squared plus 2x squared times e to the power of x squared, and the result is e to the power of x squared times 1 plus 2x squared. The next function is y equals e to the power of sine x, and u equals sine x, and y prime equals the derivative of u times e to the power of u. So y prime equals the derivative of u with respect to x equals cosine x times e to the power of sine x. The next function is y equals ln or natural log of x squared plus 2x plus 1 to the fourth power. And we should know that ln or natural logarithmic functions are inverse function of exponential functions like e to the power of x, and the derivative of ln x with respect to x equals 1 over x, and the derivative of the ln u with respect to x equals the derivative of u with respect to x times 1 over u. And for this function we can assume that u equals x squared plus 2x plus 1 to the fourth power, and the derivative of u equals 4 times 2x plus 2 times x squared plus 2x plus 1 cubed. So y prime equals the derivative of u times 1 over u, which equals the derivative of u equals 4 times 2x plus 2 times x squared plus 2x plus 1 cubed over u, which is x squared plus 2x plus 1 to the fourth power. And we can simplify this fraction, and this expression is 1, and this expression is x squared plus 2x plus 1, and y prime equals 4 times 2x plus 2 over x squared plus 2x plus 1. And the last function is y equals ln of e to the power of x plus e to the power of 2x. And we can assume that u equals e to the power of x plus e to the power of 2x, and the derivative of u equals e to the power of x plus 2 times e to the power of 2x. So y prime equals the derivative of u times 1 over u. So y prime equals the derivative of u equals e to the power of x plus 2 times e to the power of 2x over u, which equals e to the power of x plus e to the power of 2x. The next question shows that the derivative of the ln of x to the power of n with respect to x equals n over x for all integers n is greater than or equal to 1. And for proving this formula we can use two methods. The first method, the derivative of the ln of x to the power of n with respect to x equals n over x for all integers n is greater than or equal to 1. And we can assume that u equals x to the power of n, and the derivative of u equals n times x to the power of n minus 1, and the derivative of the ln x to the power of n equals the derivative of u times 1 over x to the power of n, and the result is the derivative of u equals n times x to the power of n minus 1 over x to the power of n, and this is 1 and this is x, so the result is n over x. And the second method, we can write ln of x to the power of n equals n times ln of x, and the derivative of the ln of x to the power of n equals the derivative of the n times ln x, which equals n times 1 over x, and the result is n over x. And this is the second method. We finished all these problems, and I hope you have enjoyed this video. Thanks for watching. Bye.